Hello, I'm Hallam-Baker with Komodo Group, and I'm going to be talking about using DNSSEC to enhance web security. The biggest problem we face with web security today is that security is optional. It's the optional extra that's brought out for special occasions. And that means that we're much less secure than we could be, because on the web you're only secure as long as you're watching your security. And to be honest, trying to teach end users that it's their responsibility to be in charge of security is wrong. It's not the user's responsibility, it's ours, it's designers. So how do we fix it? Well, there's two approaches we can take here. One is the strict security approach of putting a security upgrade header in HTTP saying this site will always be encrypted. Now, this is good in one respect, and that is that this approach doesn't depend upon anything else. You just add the header to HTTP, you add it to the website, you're done. Besides that, however, it's really not ideal. The security you're getting is only going to be retrospective. I can get a secure connection in the future after I have already achieved a secure connection. The other problem is that what we're doing here is only going to apply to HTTP, but the internet is more than just the web, and the security of internet services and enterprises connected to the internet depends upon much more than the security of the HTTP protocol. So if we're going to attack this problem in the large, we need to look at a layered approach and a security upgrade header that's embedded in the discovery process, which for the internet means embedding it in DNS. This is an infrastructure approach which is good in that it applies to any protocol. The downside is that we can only use this approach when we have DNSSEC deployed, and so we depend upon an infrastructure that's currently in deployment. So we've got two approaches. Which should we take? Well, I think we should do both. We do the tactical HTTP based approach that gives us real value in the short term, but long term we need to be looking beyond that and making the whole internet secure, safe and secure, not just one protocol. Why DNS? Well, it's what the DNS is for. The DNS is the discovery mechanism. And if the DNS can't handle this, then we've got something wrong. Now, I don't think that we have anything wrong with the DNS, because the DNS has been growing over time naturally of its own accord. When it was first proposed, it was essentially just a replacement for the host.txt file mapping a name to a host. But pretty soon, people realized, well, with DNS, we don't just have to map a name to one host, but could be multiple hosts supporting that service. And then people started to look at round-robin DNS and the limitations of that for HTTP, and they started to look at MX records in mail, and they generalized that to produce the SRV record, which generalizes DNS to be mapping names to generalized internet services. And all I'm proposing here is extending that one stage further, so the DNS is now mapping a name to a service location and service properties that allow us to access that service in the proper manner. How do we go about it? Well, there are some complex design choices. I don't want to go into them all here and now. However, there are issues to do with the way that DNS is constructed, CNAMEs, DNAMEs, other types of aliases. There are wildcards. Those are issues that have to be thought about pretty carefully if you're going to have a mechanism that's going to be compatible with them. I think I've got a solution that is compatible, but it's taken me a very great deal of time to get there. There are enhanced discovery mechanisms, that SRV mechanism that Paul Vixie produced that I mentioned earlier, URI-based discovery, NAPTA-based discovery. I think that these mechanisms could, in principle, be really great news for the performance of HTTP going forward. And in particular, they give us features that are going to be absolutely critical when trying to do web services in the large. SRV provides us with fault tolerance, robustness, fault failover. Really great stuff. So there's a question about how we're going to interact with those, whether we're going to use them, support them, whatever. There's a question of granularity. Do you want to be declaring protocol attributes that apply to a whole domain, or just one service within that domain? Perhaps if you've got multiple hosts delivering that service, you want to have protocol attributes that apply to specific hosts. And of course, whenever you're looking at changing the way that you're using DNS, you want to have an eye on efficiency and the number of round trips that you're using. So there are a lot of design choices. I'm not going to go into those in detail. However, I did want to make clear that I've been thinking about these, and I think that there are good answers for them. My favourite approach at the moment, I have a proposal out there, ESRV, that's in the Internet Drafts repository. Since then, I've tweaked it a little and improved the efficiency. This is showing you the efficiency improved version. So we have a DNS zone here. It's describing the configuration for example.com. First two records are just standard DNS records. We have an A record, we have a CNAME that's mapping www.example.com onto the canonical name example.com. Just bread and potatoes DNS stuff. Next three records are new records, ESRV records. First two apply to every protocol in the domain. First one is declaring the CA certificate under which all services in this domain will have their certificates issued. So if the site has a enterprise-wide PKI already installed, they put their CA or their cross certificate in this slot, and that would ensure that only the certificates that they're issuing are going to be used for services at their site. Next record down is kind of like a bit of a glue record. What it's saying is that there's more detail that can be discovered using the prefix mechanism from SRV. So here, when we do the lookup for HTTP, we will look at the protocol prefix for HTTP underscore HTTP underscore TCP, and we'll discover this additional piece of detail, which is that TLS is required for any connection. So this approach is essentially duplicating what is done in strict security for HTTP alone, but it's doing it for all HTTP connections, not including the first one, and it's also doing it in a way that's extensible to web services and other internet protocols, SMTP, IMAP, etc. Now we can combine this approach with standard SRV records. Here we have an extended example. First two records are the same as before. Next one is saying we've got detailed discovery, but this time it's using the SRV mechanism. Could use NAPTA, could use URI, could use an exciting new discovery mechanism that we have yet to invent that would optimize HTTP. Could offer multiple mechanisms. And then we have two SRV records saying that we have two hosts with an equal weight. And then underneath that we have individual security attributes that bind to the particular hosts. And each host is saying TLS is always required for this host, and here is my end entity certificate. So those are two examples of how we could use a mechanism like this. Very simple stuff that I think is a natural extension of the type of approaches that DNS administrators are already familiar with. It's something that I believe can be mechanized using scripts, and I think works from an overall DNS architecture point of view. How does this affect performance? Well, there's no impact using this extended discovery mechanism unless you're using the features. And what I'm proposing here is to do the strict security job right using DNS. I think that DNS is definitely the right tool for the job, but doing it right is going to take time. And so the approach that I'm suggesting is that we continue with doing HTTP-based strict security in the short term, but in parallel work on a longer term DNSSEC-based approach and start off doing that as an experimental approach so we can get experience in from the field and see what works performance-wise, what type of protocol attributes you'd want to put in here, what are the bugs, etc. This, of course, will require work across two different parts of the IETF. There's going to be one part that is framework that naturally applies to multiple protocols that would more naturally belong in DNS space. But when we look at how we apply this to individual application frameworks, that is something that I think needs to be considered separately for each protocol. So WebSec would be one place where I see us doing this. I think we would be doing more on email security, web services, and so on. So in conclusion, I think using DNSSEC is the right approach, but doing it right is going to take time. It's not something that I think that we should rush into and try to do overnight. Thank you very much.